Hello students, in this lecture we will start the new chapter System of Particles and Rotation Motion. A particle is an object whose mass is finite but whose size and internal structure can be neglected. A system is a collection of very large number of particles which mutually interact with one another. A body of finite size can be regarded as a system because it is composed of large number of particles interacting with one another. Internal forces. The mutual forces exerted by the particles of a system on one another are called internal forces. These forces are responsible for holding together the particles as a single object, whereas the forces outsidely exerted on an object by any external agency is called an external force, and such a force changes the velocity of an object. Rigid body. A body is said to be rigid if it doesn't undergo any change in its size and shape, however large the external force may be acting on it. Or you can say that a rigid body is one whose constituent particles retain their relative positions even when they move under the action of an external force. A rigid body cannot be deformed. If the body undergoes some displacement, every particle in it suffers the same displacement. So, such type of motion will be the pure translation motion, in which at any instant of time, every particle of the body has the same velocity. As you can see in the diagram, the motion of a block down an inclined plane. Here the points like P1 and P2 of the block moves with the same velocity at any instant of time. Next type of motion is a rotational motion. In rotation of a rigid body about a fixed axis, every particle of the body moves in a circle which lies in a plane perpendicular to the axis and has its center on the axis. The figure shows a table fan rotating about its axis perpendicular to the screen and the motion of a fan and its axis of rotation. A rigid body rotation about y-axis. In precision, the axis of rotation is not fixed, but the point of contact is fixed. At any instant, this axis of rotation passes through the point of contact. For example, in case of spinning top, the point of contact O with the ground is fixed, but the axis of rotation passing through this point is rotating about y-axis. And the axis of rotation describes a cone with its vertex at O. Similarly, in the case of fan, thus you can say that In precision, the axis is not fixed, but one point on the rigid body is fixed. Now, translation plus rotation. Both the motions you can see in the figure. Rolling of a cylinder on an inclined plane. A wooden or metallic cylinder rolling down the inclined plane undergoes both translation and rotatory motion. The velocities of different particles P1, P2, P3 and P4 at the same instant are different depending on their locations in the body. The velocity at P4 is 0, as the velocity of any particle coming in contact with the surface of the inclined plane is momentarily 0 if the body is rolling without slipping. Newton's laws of motion are applicable to point objects. The introduction of the concept of center of mass enables us to apply them equally well to the motion of finite or extended objects. Center of mass of a body is a point where the whole mass of the body is supposed to be concentrated for describing its translatory motions. The center of mass of a system of a particle is that single point which moves in the same way in which a single particle having the total mass of the system and acted upon by the same external force would move. For a two-particle system, consider a two-particle system along the x-axis with masses m1 and m2 at the distances x1 and x2 respectively from the origin. As shown, the center of mass of the system is that point C which is at a distance x with subscript cm from O, where xcm is given by m1x1 plus m2x2 upon m1 plus m2. xcm can be regarded as the mass weight mean of x1 and x2. And if the two particles have the same masses m1 equals to m2 equals to m, then xcm will be equals to x1 plus x2 by 2, means it will be located at the midpoint of the two masses. There is no need to derive this formula. You can just remember it and apply in the numerical problems because the derivation is not in your syllabus. For a three-particle system, consider three particles and the formula will be m1x1 plus m2x2 plus m3x3 divided by the total mass for x coordinate and similarly for the y coordinate. So, if we generalize this one for n particle system, the center of mass will be the sum of the m1x1 up to mnxn divided by the total masses of the particles. And in the form of summation, you can write the summation I is equals to 1 to n mixi divided by summation of mi from I is equals to 1 to n.